Okay, here we go. Today, everybody, we are going to cover the human body. If time permits, we'll do checking an unconscious person. When I say cover the human body, I'm going to show you a short video, and then that's it for covering it, though. I just want you to learn, based on my objective, to be able to identify the body cavities and describe how each one works. And it's essential for it to have proper functioning of the body. If your body cavities are not all functioning together, if one of them is breaking down for some reason, that means the others have to work harder, which could cause you even more grief. Okay? So that's a big thing.
Thank you.
You trying to rob me, or what are we doing here? All right. Tomorrow, if I don't get through all of unconscious person, I will wrap it up to begin class, because it is a smaller group here, and then I'll teach you how to actually check the unconscious person, and we'll do the hands-on testing. Very simple. Friday, we're doing the Bill Nye circulation video. Okay? Make sure those of you who got less than 8 on the quiz today, you look over those notes again. If you need to take your packet, feel free. But you should know the 6 carries, the 3 call first, and the 2 care first situations. And we'll retake on Friday. Here's your reminders. Your fee is due next Friday. How many of you are still planning on paying the fee that haven't paid it yet? Okay, so I do have a handful of you. If some of you have an issue with getting the money into me, just talk to me. I really don't think you should take the class and not strongly consider paying the fee, because this ends up working out to be a good thing for you. Also, current events. This is the only class that nobody has turned one in advance. If you're in the blue group and you know who you are, I've gone over it a number of times, your current event, first one, is due this Friday. Okay? Any questions about any of that? Dylan?
It's 7. You wrote for the human body 9/6.
Yeah. You know, it is what it is. There are some of you who have not joined Classroom. I think just a couple of you. Or haven't joined Remind. I will speak with you. Okay? We'll make sure that's taken care of. Or I may have already spoken with you, but we need to make sure that you take care of that. All right, so let's get started with the human body. I have a fun little clip to start with. Everybody remember Schoolhouse Rock from when they were a little kid? Yeah, here you go. I got a nice little Schoolhouse Rock.
There's a great new craze that's sweeping the nation. Come on, do circulation. Starts with your heart, what a great sensation. Come on, do circulation. Out through your arteries, into your veins. Your heart pumps your blood, then it does it again. So come on, everyone, get it on, everyone. Circulation. So come on, everybody, exercise your mind for circulation. Circulation, everybody move a circle now. Circulation, not your blood, you just start.
squats, Rocco. Or not. It's up to you guys. Okay, so I went over essentially the objective today, looking at the 5 body cavities and the major structure of the cavities. In your packet on page 14, let's do this little quick warm-up. Try to match up the numbers with the letters. You know, which one of the letters do you think is the abdomen region? Which one do you think is the cranial region? Thoracic, pelvic, spinal? It's pretty simple. Do you have a writing utensil, bud? Okay.
It's like 6 years old. He's in his bed driving the car.
Anybody need more time? Out. Okay. So, number 1, abdomen. What is it? It is your stomach, exactly. Cranial?
There we go. Head, skull.
It is head, skull, short. Thoracic?
Chest.
Chest, sure. Pelvic region?
Head, genital.
Right, groin, genital area. And the last one, spinal?
Backbone.
Yeah, obviously. Do you think you could function properly if one of those was not working well? No, absolutely not. And it was, I put that question out there first period. Somebody said, well, you could probably go ahead and get along without the pelvic region. And I said, do you really think you could do that? You know, you think about all that it encompasses. Do you really think you could function well? You know, so. Okay, so the major body cavities. This is in your packet on page 15. There are very few notes today. Major body cavities are the cranial, your head, your brain is in there. The spine, which is your backbone, you know. Thoracic, your chest area, protects the heart. Your abdomen, that's what's protecting like your lungs and your kidneys and then obviously your pelvic area. And you know, that's needed for reproduction, it's needed for getting rid of waste in your body. Everybody good? All right. So each body system has a vital role in survival. If a body system works together to maintain a constant healthy state, you're fine. They depend on each other, though. Those 5 things depend on each other. Okay? The impact of an injury or illness is rarely restricted to one body system, though. And the reason that occurs is when something breaks down in one area, the other areas of your body try to make up for that. And that's where you run into issues. Now here's your definition for shock. Shock is a progressive failure of body systems. This is another part of your notes, okay? So it's a progressive failure of body systems. Go ahead, Dylan.
We have the major body cavities at the bottom of the foot.
That's fine. You'll remember it more by writing it, and that's why I always put it in there like that. If I think it's super important from that perspective. And there's so little we cover in terms of the makeup of the body. We just cover how to handle the injury aspect of it. One of the questions that was asked this morning is, how do you get shock? Well, it varies from person to person. What might be detrimental to you mentally and physically that could send you into shock might not be the same for somebody else, to be quite honest with you. I gave the example of my one daughter and my wife, and actually my two younger daughters and my wife were on their way to softball, and this is a couple of years ago when a girl pulled out right in front of them. They were going 55 miles an hour on a kind of a back road, two-lane highway, or two-lane road to softball practice. And when I got there, everybody was okay, thankfully. The car was just trashed. But, it's been impactful for my wife. She has PTSD to a certain degree from it because of how quickly and how high impact it was. But anyway, when I got there, the one paramedic pulled me aside. He said, "Your wife's doing okay. Your younger daughter's completely fine." My younger daughter's, she was like, I dropped some stuff in the back of the car. She was just really, like, it was not impactful to her from that perspective. But my older daughter, who was 12, I want to say at the time, she was either 12 turning 13 or just turned 13. He said, I started asking her some questions because she was sitting in the front seat, and he said she was fine, and then she started zoning out, which means she was going into shock. And I said, well, how did you handle that? And it was just from my own personal knowledge. And he said, I just brought her back to the original questions and took the focus off of things that were making her kind of zone out. So for each individual, again, it can be different. Our human body is made up of a ton of cells. Similar cells come together to make our organs. So our organs are all a bunch of cells. The 3 vital organs you need to write down are the brain, the heart, and the lungs. The brain, the heart, and the lungs. You can replace the heart, you can replace the lungs, but you cannot replace the brain. Because if you could, I can name a lot of people I know that would need brain transplants. But that's a joke, everybody. Relax. Thank you. Appreciate that. It takes the onus off of my jokes, even when they're bad ones. But again, all the systems have to work together for you to function properly. So the brain, the heart, and the lungs. What are the 3 vital organs?
Brain, heart, and lungs.
Thank you. Okay. If I hurt one area of my body, is my whole body functioning improperly or just that area? Whole body. Thank you. Okay. So this is about our human body, and this will most likely take us up to the end of class. It just shows you how the body functions and works together. It'll show you each of the different areas.
The human body is a highly sophisticated machine. It performs many complex functions, each of which helps us live. The human body is made up of billions of different types of cells. Cells are the basic units of life and contribute in special ways to keep the body functioning normally. Cells divide and specialize to form different kinds of tissue. Tissues make up organs, and organs make up the various body systems. This video will review each of the major body systems. Understanding how the body systems work to sustain life will give you a better idea of how to respond in an emergency. Let's begin by looking at the musculoskeletal system. The musculoskeletal system is a complex framework of bones, ligaments, muscles, and tendons. It is made up of the muscular and skeletal systems. The musculoskeletal system supports the body, protects internal organs, allows movement, and produces heat and blood components. The muscular system consists of 300 pairs of muscles and tough connective tissue bands called tendons, which attach muscles to bones. Muscles are made of special tissue that can contract or shorten and relax or return to their original length to produce movement. Tiny electrical signals called nerve impulses stimulate muscles to contract. There are 3 types of muscles. Skeletal muscles, or voluntary muscles, help give the body its shape and make it possible to move, such as when smiling, talking, or walking. Smooth muscles, or involuntary muscles, are found in the walls of tube-like organs, ducts, and blood vessels. Cardiac muscle is a special type of involuntary muscle that allows the heart to contract and pump blood. The skeletal system includes bones and ligaments. Bones are the hard, dense tissue that forms the skeleton. They vary in size and shape in different body regions and include the skull, spinal column, thoracic cage, the shoulder and upper extremities, and the pelvis and lower extremities. Joints connect bones with each other. Strong connective tissue bands called ligaments hold the bones at the joint together. All joints have individual degrees of flexibility and movement. Some of the larger joints of the limbs are indicated here. The respiratory system breathes life into the human body. It supplies the body with oxygen, which all cells need to survive, and it also removes carbon dioxide from the body. This is done through the breathing process, called respiration. Breathing in, or inhaling, brings air into the lungs through the airway. First, air enters the body through the mouth and nose, where it is warmed, humidified, and filtered. Then air moves progressively down the upper and lower airways, until it reaches millions of tiny thin-walled air sacs called alveoli. Here, oxygen passes into the bloodstream, and carbon dioxide passes from the blood into the alveoli. When breathing out or exhaling, the carbon dioxide is expelled from the body. At rest, the average adult breathes between 12 and 20 times a minute in a steady rhythm. We can observe respiration by watching the chest rise and fall as the lungs expand and relax. The body stores enough oxygen to last for several minutes. If the oxygen supply is cut off, brain cells will start to die in 4 to 6 minutes. The circulatory system includes the heart, blood vessels, and blood. Its primary function is to transport oxygen, nutrients, and other essential chemical elements to the body's cells, as well as remove waste products such as carbon dioxide. The circulatory system is driven by regular contractions of the heart muscle. A normal adult heart beats at an average rate of 60 to 100 times a minute. As it does, blood is pumped throughout the body. Oxygen-rich blood moves from the heart to the body through large blood vessels called arteries. These branch into smaller vessels, eventually delivering oxygen to the cells through tiny, thin-walled blood vessels called capillaries. Capillaries also receive waste products and carbon dioxide from the cells. While waste is removed from the blood, blood vessels called veins deliver carbon dioxide and oxygen-depleted blood back to the heart. The heart itself is the central organ of the circulatory system. It is divided into 4 chambers: the right atrium, left atrium, right ventricle, and left ventricle. The right and left sides of the heart play opposite yet complementary roles in the heart's continuous cycle of receiving and pumping blood to and from the lungs and body. The right atrium receives oxygen-depleted blood from the veins of the body and delivers it to the right ventricle. The right ventricle then pumps the blood to the lungs for oxygenation. The left atrium receives oxygen-rich blood from the lungs and delivers it to the left ventricle, which then pumps the blood back to the body through the arteries. The force of the blood flowing through the arteries is called blood pressure. These individual processes of the left and right sides of the heart occur simultaneously. In addition, with every heartbeat, a wave of blood moves through the blood vessels. This is called the pulse. The pulse can be felt at several pulse points in the body, where arteries pass near the surface of the skin and over a bone. Examples include the carotid pulse point in the neck and the brachial pulse point on the inside of the upper arm. The nervous system is the most complex and delicate of all body systems. Along with the endocrine system, the nervous system regulates all other body systems. It also transmits messages to and from the brain. There are two main anatomical systems of the nervous system. The first of these, the central nervous system, is made up of the brain and spinal cord. The brain is the master organ of the body. It controls sensory and motor functions, as well as the integrated functions of consciousness, memory, emotions, and use of language. The second anatomical system of the nervous system, the peripheral nervous system, is made up of the nerves outside of the brain and spinal cord. Within this system, electrical impulses carry information back and forth between the body and the central nervous system. Within the peripheral nervous system are two functional systems that are responsible for this constant communication with the brain. The first is the voluntary system. In the voluntary or somatic system, impulses travel from the nerves to the brain to register sensation such as touch and taste. The voluntary system also controls impulses from the brain out through the nerves to direct motor function, or movement of the body. The second functional system of the peripheral nervous system is the autonomic system. The autonomic system controls the involuntary muscles of the organs and glands. This includes functions such as the heartbeat and digestion. The most basic indication of a properly functioning nervous system is consciousness. The degrees of consciousness can vary from unconscious to very alert, but at all times, our awareness of the world and control of our bodies depends on the integrated performance of our nervous system. The integumentary system includes the skin, hair, nails, and the sweat and oil glands. This system protects the body, regulates fluid balance and body temperature, produces vitamin D, and stores minerals. The skin, the largest organ in the body, is divided into two layers. The epidermis, or outer layer of the skin, contains melanin. Melanin is responsible for skin color. The dermis, or second layer of the skin, supplies blood to the skin, hair, glands, and nerves, contains immune cells, and determines the skin's elasticity and strength. Subcutaneous tissue lies deep to the dermis and is composed of loose connective tissue and variable amounts of fat. Both the skin and subcutaneous tissue can vary in thickness depending on the body region. The skin helps the body retain fluids and keep germs out. When the skin is scratched or cut, germs, which can cause infection, can enter the body. The skin also helps maintain body temperature. If blood temperature rises, even slightly, perspiration is created and released through openings in the skin called pores. As perspiration evaporates, it cools the body. Blood supplies the skin with nutrients and can affect its color. When blood vessels widen, blood circulates close to the skin surface and makes skin appear flushed or red and feel warm. As blood vessels constrict, less blood is close to the skin's surface, causing the skin to appear pale or ashen and feel cool. Finally, the nerves in the skin are very sensitive to touch, temperature, and pain, which makes the skin a vital part of the body's internal communication network. Together with the nervous system, the endocrine system regulates other body systems and plays a more significant role in the human body than most realize. The endocrine system influences traits such as strength, stature, hair growth, and behavior, controls blood glucose levels by the production and secretion of insulin, and helps to regulate water and electrolytes in the body. The endocrine system is made up of ductless glands. These glands secrete hormones, which are the chemical substances that enter the bloodstream and influence activity in different parts of the body. For example, the adrenal glands secrete epinephrine or adrenaline, as well as norepinephrine or noradrenaline hormones. Stimuli such as stress can trigger secretion of these hormones. This triggers physiological changes to prepare the body to react as it needs to. For example, an increased heart rate prepares the body to run if danger is present. Other glands include the pituitary gland, or master gland, which regulates growth, and the other glands. The pineal gland, which regulates waking and sleeping. The hypothalamus, which secretes hormones that act on the pituitary gland. The thyroid, which regulates metabolism, growth, development, and nervous system activity. And the gonads, which produce hormones that control reproduction and sex characteristics. In women, these are the ovaries. In men, these are the testes. The digestive system serves as the processor of the human body by making best use of the food we eat. The digestive system contains organs that break down food, absorb nutrients, and eliminate solid waste. Food enters the digestive system through the mouth. Digestion begins here, as food is chewed and swallowed. Once swallowed, food travels down the esophagus. The esophagus is the passageway that leads to a major organ of the digestive system, the stomach. Once food reaches the stomach, enzymes begin to break the food down into smaller components. Food then travels from the stomach into the small intestine, where further digestion takes place and nutrients are absorbed. As food enters the small intestine, bile from the liver and pancreatic juices from the pancreas complete the digestive process. Blood containing nutrients and toxins is sent to the liver for modification and processing. Fats are also absorbed before they can gain access to the blood system. Solid waste products then pass into the large intestine, where water is absorbed. The remaining waste is passed through the rectum and anal canal. Finally, let's take a look at the genitourinary system, which is composed of the urinary and reproductive systems. The urinary system filters wastes from the blood, eliminates waste from the body, and helps the body balance fluids and electrolytes. Two of the major organs of this system, the kidneys, are located behind the abdominal cavity. The kidneys filter waste from the circulating blood and form urine. The ureters transport the urine from the kidneys to a small muscular sac called the bladder. Urine is stored in the bladder until it is ready to be eliminated from the body via the urethra. Buffers in this system balance fluids and electrolytes by controlling the acidity or alkalinity in the urine. This acid-alkaline balance is called the pH. The reproductive system is responsible for the origin of human life and is composed of the male and female reproductive organs. The male reproductive organs include the penis, a duct system, testicles, and the urethra, which is also part of the urinary system. Because these organs are located outside of the pelvis, they are vulnerable to injury. The female reproductive organs include the ovaries, fallopian tubes, uterus, and vagina. Unlike the male organs, the female structures are internal and protected by pelvic bones. During a 28-day menstrual cycle, the female ovary will release a single egg. If the egg is united with a sperm, which is contained in semen that is ejaculated through.
Okay. So the rest of this you get in health. Have a great day. I'll see you tomorrow. Don't forget, quiz retake Friday. And bring your kids tomorrow.